If you've ever played D&D, or maybe you just needed a map at some point, you're probably familiar with Watabou and all of his generators, like this medieval fantasy city generator, where it'll generate you a city under your presets that you have set up, and you can generate a new one just randomly and make yourself a new map. And then you can use this for whatever you need, whether it's D&D or anything else. But now, thanks to a Watabou Bridge plugin created by the creator of PCGEx, Tim, we can now take that data and bring it into PCG and actually have all that information all within actual Unreal using PCG. Now, while this is all just using the debug stuff, it still has all the information you need to just start spawning whatever you need in the exact locations that you've generated. And it's actually surprisingly very, very easy to do. So what I want to show you guys is how do you use the Watabou Bridge plugin and how do you create something like this, of course, with a new generation that I'll be showing you guys. So you can customize and build upon it, whatever you need. And if this is something that you're interested in, let me know in the comments and I'll happily build upon it and continue to expand what I can show you guys with the plugin. So with that, let's get into it. The first thing you're going to need to do is, of course, enable the plugin after you have it installed. So go to Edit Plugins, search for Watabou, and make sure you have Watabou Bridge turned on. Now, by default, it only needs the default PCG plugin to be enabled. So as long as your PCG is enabled, you're good to go. In my case, I'm also enabling PCGEx. As I mentioned earlier, it is created by the creator of PCGEx, so there's quite a few benefits to using it. It is not required, but I'll show you like a note or two here in PCGEx that will make you want to immediately start using it as well. The primary focus will be, though, on Watabou Bridge and using it. So once you have those plugins enabled, go ahead and restart the editor if needed, and then you should be good to go. To get started, we need to get the data that you're actually going to be using. To do that, go under Tools, and down below, you'll see Watabou Bridge. Go ahead and select it, and it will bring up this screen, where you now have options of generating different kinds of setups here. Dungeons, towns, cities, locations, whatever you need. So for example, you can make a little village, you can make an entire city. We'll go ahead and just make a village, and you'll notice that these have buildings. We can actually generate the information for those as well because there's dwellings, which are basically buildings. So let's go into this village generator. We'll go ahead and use this one. So we have a seed, so you can just randomize it to be of a different setup here. We can change the size here. So for example, if I made this 1000 by 1000, right, you can have a bigger one. So if I randomize it now, you'll see it's expanded to a larger area. I'll go ahead and continue having this be a little bit smaller. We also have customization here. Now, the population is only kind of for displaying. The name, same thing. If I just type in village here, right, it'll just replace the name. It's not really that important for what we're doing, but you can absolutely say, hey, this is a village called Village with a population of 420 people. Right, and there you go. So if you want to have this actually just be like an image where you can use, there is all your stuff. Now, you could specify the density, so I can have it be relatively sparse, so very few buildings, or I can specify it's very dense, so there's quite a few more, and you can see when I select one or the other, right, it only does one or the other. I can also give it a river to go through. So now there's a river going through all of this, or it can be by the coast, or it's an island, a pond, right? And the main thing here is you have customization of how do you want this actual village to work. Let's just do a simple river here, maybe. And then we could specify roads. Is it an isolated area? Is it going through a highway? So there's, you can see there's the road going all the way through the town. Is it a dead end? So the road kind of goes here and then it ends at the village. Crossroads means there's multiple paths to go through. So if I re-roll this a bit more, you'll see there's now more paths, although it's still doing 2 mostly. It's probably a very small location. But I guess a crossroads doesn't necessarily need to have 4. And then we could change the field. So for example, we could do farmland, so we get a lot more farmland. Uncultivated means no farmland at all. And no orchards means, well, a little less farmland, basically, right? I'll just go with farmland. I think it looks nice. And then we can change things like the features, so we can make it a little more organic. So if I turn this off and on, you can see we get a bit more trees here. We can make this a grove. So if I turned off the trees, right, you can see this effectively makes it, so there's only some trees right here. Everything else is kind of barren. We can give it some districts. So now it's actually expanded further. So you can see by not having districts, right, it's mostly just a little town here. By telling it to have a district, now we have an area here, right? We have effectively created districts in this small little town. a palisade, could be a wall, and we can turn off the square. And the square here is that area right here, right? So this is kind of the central square of the town, if you will. So if we want to, we can have it, for example, be organic and have something like this. I mean, just, you can randomize it now and see if we can get one that looks kind of nice. And this is pretty good. I kind of like this one. And let's say I am happy with this. Let's say this is the kind of the setup I want. I've randomized it what I need. This is what I'm looking for. Now, quick note here. What you see is what you get in terms of data. So if you're like, oh man, I really want to maybe move these buildings a little bit to the right. Well, you can't do that in here. You're only getting basically the data from this generator as it is. So that means where it's cut off, it's cut off. Now, that doesn't stop you from creating more data and reusing maybe some pieces, right? And putting them somewhere else, like more manually and expanding upon it. But if you're planning to have it be a larger area, maybe you should build into that automatically. Or go ahead and use one of the bigger generators. So that way you build maybe the giant coast all with it, and then the cities and then the buildings, etc., kind of as you go in. Again, let's say we're happy with this. We have the import settings here. Import recursively is quite a nice thing here. After each successful manual import, walk the asset for nested seeds and import each one through the headless pool. Continues until the queue drains. Basically, this will bring everything in on a lower level. So this is a village. The village has, well, houses. So it will actually bring in the dwellings, as they're called, and give you a layout of all of these if you wanted to import recursively. Otherwise, you would just have the information of where these buildings go. So for example, if you have pre-made buildings, you could just use the default map and just place the buildings where you need. If you want to also make the buildings procedurally, right, you would want to import recursively and it'll bring the ones inside of that one. Now, I believe it only goes one deep. So if you were to do this like on a full coast map where you have a bunch of towns, it would bring the towns in, but it wouldn't then also bring the buildings in, I believe, from my understanding. But that doesn't mean stop you from putting in whatever you want regardless. I'll show how that's done with the buildings, so that way it kind of makes sense. So if you wanted to, you could. Once we have this, we're just specify location where we want to put it. I'll just leave it on the default. That's fine. All we need to do then is hit import. And then it's going to try to doing its thing. Now, I have seen it fail. And that's just like when it can't find a building, for example, it can fail. And while I was talking about that, it has finished. And if you're wondering, this slots is basically how many hidden browser tabs is it going to use to actually calculate and download everything. So the more, of course, the faster, but it uses more memory. So if you're downloading, let's say, a giant map, you might want to increase this number. For something as small as this is fine. But once you hit import, we can take a look here in the content browser. Here under Watabou imports, we have our village. So we can click and open it, and we get this, which has all of the information of this village. So for example, it has the bounds, it has the generation tags, here's what we used. And at any point, we can actually close this entirely. And just by having this open, we can click open in import window, and it'll reopen it to the exact configuration, exact seed and everything, so you have access to it again. You can see here the village and the foreign population, right? It's still all here. So it maintains all the information, so you could grab this if you wanted to, but it just doesn't affect anything in terms of placement. So cool, we now have the piece of data that we need here. And if we go here in the content browser, we can see in this folder, you can open the DW folder for dwellings, I believe. There's all our dwellings, and I can just open any one of those, and there's the information of the dwelling. Now, quick note here, you see how this has an asterisk here? Well, make sure you hit Control-Shift-S to save everything, because not everything is just automatically saved. So as soon as you import it, just hit save, so that way if something happens, if it crashes or something like that, everything is saved and you're good to go. So that's how you bring that data in, but how do we actually use and filter out that data? Well, that's of course with PCG. So let's go ahead and go here in the content browser, right click, go to Procedural, PCG graph, and I'll make itself an empty graph. I'll just call it PCG Village, and I'll just drag down to the world. And now let's go ahead and open it. First thing, of course, we need to do is know where it's going to place it. So I'm going to right click and just use a get actor data. We're going to use the spatial get actor data here. And I just want to grab the single point that basically is the bounds of the entire thing. If I go ahead and press D here, you can see it is now the bounds of this actual location. And if I go ahead and let's say scale the X and the Y to 100, right, it has gone bigger. So the single point maintains basically the full information of this bounds. So with that, I can use one of the two new nodes. I can just drag out the out and search for Wata, and there's Watabou generate. So we can go ahead and grab it. And here, In the detail panel, you can see we can specify the asset. So in the drop down here, you'll see all of your actual assets effectively, right? Because we did recursive, so we got all of the buildings that are kind of part of it, and all the way at the bottom here is the village itself. You can of course plug it in directly. So we'll go ahead and just pick it. We're on source mode picker, so we'll just go ahead and pick it. Now at this point, I could go ahead and just press D to debug it, and you will see, hey, there's the village. There's all the points for everything. But let's be honest with ourselves. This is cool, but this is not super usable as of yet, right? How do we now specify that's the building? How do we know where the road is? Like, I can visually see it, but right, we need to filter it all out. And thankfully, filtering it all out is easy. But the main thing here is if I pressed A here and I look at this drop down, right, we have a bit of information for the tags of every place. But if I change the points here to data, we don't have much data about this place. So I want to grab a bit of data. If you drag out and search for water again, you will not see any other node. Right now in 5.8, contextual is broken. If you turn this off, you'll actually see there's another Watabou thing. Watabou load properties. If I go ahead and use that and just plug the feature map right into feature map and press A here, you will see there's our feature ID, the generator we used, the version, the road width, and the wall thickness. All information you're probably going to want to use at some point. So I recommend loading the properties that we need from there. It's also useful to just save this feature map if you so need it down the line. You can just drag out, search for name, and add named reroute declaration node. I'll just press F2 to rename it, and I'll just call this village map. And then we can just plug that all the way through into the feature map, just like so. So cool. So we now have everything loaded. This is actually all you need to load it. But again, if I was to debug this, right, we still have the same points. Nothing has been filtered. So let's talk about filtering. In here, you can see we have different tags for things. There's buildings, there's fields, there's water, there's some trees, so we can actually filter everything. The only thing I'm going to do first, though, is change the seed, because if we take a look here at these points, they all have a seed of 0. If I select any other one, every single one will have a seed of 0, and we really need them to all have unique seeds, or everything's going to be exactly the same. So to do that, we'll just use a mutate seed node. So now if I press A on this one, you will see that every single point now has a randomized seed, which is kind of important. Otherwise, when you did something like a transfer points, they would all move in unison, even if you put a random value in the range. Because they have the same seed, they would all effectively transform, move, whatever it is, all together exactly the same. And we don't want that. We want randomness where we want randomness. So now how do we filter? Well, it's actually very simple. We just use these tags to filter. So let's start with the buildings, for example. I just drag out and do a filter data by tag. And now I can specify the selected tag of buildings. And if I keep it just on keep tagged equal, we can also do remove tag, right? So you can get it out here or here. If I debug now these points from the inside filter of the buildings, you will see, hey, there's the points of the buildings. And each building has 4 points, but this is not very easy to see what is actually going on. This is why I'm using PCGEx. That makes things a little bit better. So instead of using this debug, I'm going to use debug paths from PCGEx. Effectively, it's going to treat this like a spline and then allow me to customize how it actually is displaying it. So just by the defaults here, I'm not even going to change anything. You could see, look at that. There's the outline of the buildings. Just like that, it's that simple. So now we can see all the buildings. Now it's a little hard to see, especially if we zoom out here. So what you can do is just change the radius here to something like 5. And now from all the way here, you could see the buildings. Now, isn't that so much better to see? Now, you can absolutely do a create spline, right? Do this whole thing, but this just allows you to very quickly preview effectively a spline of these points. So cool. So there's our actual buildings. So now how do we continue getting the rest? Well, it's the same way. We just go ahead and reuse the tag. And let's say on this one, instead of buildings, I want fields. So again, if I was to use a regular debug point here, there's the outline of all our fields. But as you might guess, it is a little bit easier to use the debug paths here. And we can go ahead and customize the color of it. Let's give it something like a yellowish golden color, maybe like wheat. And now if we take a look at this, right, you can see there's our fields. Now, if you remember, I had all those lines going through the wheat like a, well, wheat field, or like farmland, really. And this is one of the reasons I recommend using PCGEx, because there's a lot of nodes that will just help you with getting things to look right with just this data. one of those nodes is a node called path hatch. If I go ahead and select it, and I'll just plug that into the paths here, so it will debug both the outline and this hatch, you will see that when I zoom in, hey, there's a bunch of points. Now, this one's way too dense, and this one's, I mean, it hurts my eyes, so let's zoom out. Let's go ahead and tweak this a little bit. On this hatch node, I can open up the lines. You can see there's a count, but instead of count, I'm going to do distance. So that way they're always equally apart, no matter how big the actual field is. And if I just do a distance of 100, you can see here that the distance on this one and the distance on this one is exactly the same. If I change the distance here to, let's say, 250, right, we have 250, and it's a little bit hard to see. So let's adjust the debug paths here to maybe have a radius of 10, right? And just like that, there's our fields with the lines that you would need to actually create the farmland here. As simple as that. Now, yes, you're not controlling the actual direction in all of these. If you want to control the direction and everything, you would need to customize this a little bit more. But the point of this is to show that, yeah, it's that easy to go ahead and get yourself some nice farmland with the setup. So, okay, cool. So we now have some building locations. We have some farmland. Let's continue on. And by the way, you can just, out of outside filter, just use a simple debug here and just press A on it to see the rest of the information. And here we can see, oh, we have roads still. We have the squares. We have water, trees, right? So we have a few more to do. We'll go ahead and use another debug here. And let's go ahead and use the trees this time. And for the trees, I'm just going to use a transform points node so we can randomize them a little bit. I'm going to turn off uniform scale. Also go ahead and unlock these, and then I'll scale them from between 5 and 5 and X and Y and 100 and Z to something like 10 and 10 and 200 and Z. So I'm giving them quite a lot of vertical scale because they are trees. And we'll just use a regular debug here, but we'll just change the PCG cube here for a sphere. We'll just use the arcade editor sphere. It's fine. And we'll just adjust the material here to a PCG green. Here's PCG debug green. We'll go ahead and select it. So we'll just apply this material. And if we take a look, hey, there's all of our trees. Now, each tree is its own point. So if you're wondering, well, how do you place trees in the right location? No, this is actually where those trees are. Now, it doesn't have like kind of the radius of your trees, right? But this is where it is. And if you wanted to, right, I could just go ahead and use a static mesh spawner here, for example. Just turn off the debug. And on the static mesh spawner, add an entry, search for a PCG tree. And if I go and select one, and probably disable the transform points, they're probably way too big then. So we effectively are just doing the inside filter to the static mesh spawner. We probably need to actually scale down the trees now that I look at it, because they are scaling based off of the scale of the actual bounds. So we'll just use an apply scale to bounds. So that way the 100 by 100 scale that we apply to the bounds is just applied, well, actually to the bounds instead of the scale of this object. And now we can take a look. Hey, there's our trees, right? So here we can then use a transform points as we were doing before, but this time we're using the actual models. Just go ahead and scale it. And because we set it to be uniform, right, the values of Y and Z don't matter. It just goes off the X and randomize the rotation with 360 degrees. And just like that, we have the actual trees, right, placed in the right location. Easy as that. And you can see here, right, it takes into consider everything. So the trees are placed exactly where they were in the reference. For my example, I'll go ahead and go back to the actual spheres. I think it looks honestly nicer. At least at a glance from a distance, right, you can immediately tell what's going on. A little bit better with this. From there, we'll go ahead and filter out another one. This is going to be the water. And I'll use a debug paths one more time. And on this debug paths, it's water. So I'm going to make it something like a bluish color. And you can see immediately, oh, there's the water. There's the water line. So if we wanted to, we can go ahead and use it. Now, it's a little bit hard to see. Go ahead and increase the radius here to 30. Adjust the color if we want to. But you can see there, that's our actual water area. So now if we want to, right, you could go in and do an interior. You also have the spline in general. So that means that you could just spawn a nice coastline right along this. You have the information you could do on interior. If you did a spline sample, you have a lot of control here. From there, let's go ahead and grab the roads. The roads we'll do a little bit differently. We'll still need to filter out the roads. But if I was just to use a debug paths here, just like the other one, and we'll just adjust the color here. Let's do something like a little more maybe beige, and we'll just change the radius here to 10. Right, we have the roads, but the roads are just a single line. And wouldn't it be nice to have these roads actually look like thick roads, like this actual river, where you could see that's the width of the river? Well, you could do that with a simple PCGEx node, and the node is called offset, or rather Clipper 2 offset. By just using this, you can go ahead and have it selected and just adjust the offset here. And if I change the offset to something like 50, I can go ahead and keep the rest as is. It's fine. We can now take a look that, hey, the road now looks like, well, as you kind of expect. It has an actual width. We can see, there you go. That's the actual size of the road. And you have two separate sets of points that have been basically split up. Well, actually, it's technically one set of points, right? The data is still along one, because you can see here at the dead ends, it is continuing on from one to the other. But nevertheless, this allows you to really quickly have a visual of the, okay, there's the road. And if I want to, I can go back in here to the offset. And let's say I want a 200 offset instead. Well, there's the road with a 200 offsets. That's what it looks like when the road would be bigger. And based off of your positioning of things like the houses, you might want to have a thicker, thinner road, which you can very quickly preview. You can see here, based on this, the house would actually not fit here, so maybe you'd want a slightly thinner one. Or maybe you would just choose not to have the house here. You could always just use a difference node and something like a volume or a spline to cut areas out that you don't want from one of the filtered areas. So for example, if I just didn't want to have a house here, I could use a volume, right? And then just use a simple difference node set to binary and basically cut out from a volume or a spline that I want the points of the buildings here. So right here where they had the debug paths, right? It would just go in here. The thing that I'm using to cut out would be the differences, and then that would continue on. It's quite easy to remove points. Adding things and tweaking them is a little more difficult. The last one we really need to clear out here is going to be the squares. Now, not literally the shape square, but if I filter out squares, that is the kind of the area that you saw earlier where I created kind of an area of like a town square. It's not a square, it's a town square. So if I go ahead and just debug paths on this one, again, I'll just change the color here so we can really see it. Make it something like a dark orangish red and zoom out. There it is, right? That's the town square. So if you wanted to, you could place something in here and you know, that's where the area is for it with all the buildings around. Now, so this is really, really cool. We have all of this information, but like I said, it can go in deeper into here. So we can actually populate the buildings now because we did download recursively. So we have the information for all the buildings. So let's do that. Let's filter out the buildings and actually assign to them the information that we need. And also real quick, if you're wondering what's left on this outside filter, if you need it, if I just use a debug paths here, you'll see that's basically the bounds of the actual map here. And it's just connected really weird, but basically it's just the bounds of the map. So effectively that's the only thing left here on the debug paths. So that's why we're just filtering out the specific squares, and that's really the last one we need. So let's go back to our buildings here. Well, we're going to need to generate the buildings, so let's go ahead and grab the generate and load properties. We're going to need to grab the information from them, and we can use the same point from this filter to go ahead and go into this generate. The difference is on this generate, we don't want to be generating the village, right? We want to generate the building. So instead of using a picker, we'll use a seed reference. We want to know what actually we need to choose based on a pre-existing map. And the pre-existing map is this village map that we have used. So we'll go ahead and right click and select village map and then plug this into the feature map. And then back on the generate, we need to give it the seed of what we're actually trying to replace here. In our case, we want to know where are the dwellings? Because as you recall from this map, the actual buildings here, right, they're called dwellings. If I go ahead and select the actual dwellings here right below, right, that's a dwelling, right? You can reroll and get all sorts of dwellings. Some of them have multiple floors. You could actually click them and go through all of them. I'm not going to go over how to actually set all of this up, but it should give you a good start. By all of this up, I mean as in actually spawning in the walls, the stairs, etc. But if you want to know how to do that, let me know in the comments below, and I'll look into showing you guys a tutorial on how to expand upon that to actually spawn in the buildings procedurally with this. So now we know where the dwellings are. Well, we need to load the information of the dwelling. So we'll go ahead and load the properties. And then we need to filter some of the data. So we'll do a filter data by tag as we were doing before. And I want to keep the tiles. So if I was to drag out of here, right, and use a debug, just a regular one, and press A on this, we could see, hey, there's features and tiles. So basically we're just splitting up the two into their respective ones. So the top one now is the inside filter tiles, And the bottom one is the features. So if I pressed A on the filter data tag, you can see there's all the tiles because it's just showing me the inside filter. If I want to, I can change this to the outside filter, right? And there's all our features. So the features really are the main one we need compared to the tiles, which is just the locations. Now we need to go through every single one of these and actually set it up. So we'll need actually a new PCG graph that we're going to loop on. I'm going to right click, go to Procedural, PCG graph, create an empty graph. I'll call it something PCG dwellings. And then I'll go ahead and click and drag this into the graph and choose loop mode below. And then let's go ahead and double click on it to open it up. And over here for the input, I've gone ahead and customized it to have two inputs. The first one is tiles. I've set it to be a loop because we're looping on all of the dwellings of a type point. I've set it to required because I prefer to always have the inputs as required. And then the second label is the features, which are also being looped on and also set to point and required. When you have multiple loops like this, as long as the numbers match, you'll have no problem, and it will just loop on both of them at the same time. So we'll grab the first index and the first index, the second index and the second index, all at the same time. So if you were thinking that, wouldn't this just make it so you do all of them on the first and then again on the second? No. It'll go both firsts, both seconds, both thirds, etc. We actually don't need the output here, so let's move it out of the way. And we'll immediately can just take a look at the tiles because they're just going to be basically, well, the tiles that we saw. So we'll use again, debug bounds from PCGEx. I'll just give it a custom color here, just like so. And then if we go back to the main graph, I just plug both of these in. And you can see when we plug both of them in, because they're set to required, it becomes now actually fully visible instead of grayed out. And if I just go ahead and zoom in, well, those are the tiles. Those are the tiles that make up this actual building. And you can see they're a bit smaller than the actual original size that we had. So we can adjust this by going back to this Watabou generate. There's a scale factor. So if I change the scale factor to something like 1.8, it will scale everything inside of it to 1.8, which means that it pretty much fits really well inside of here. But you can see this is actually the size of the buildings inside. So now based on this, you might want to say, you know what, I want slightly smaller buildings, because actually the road is going to be a little bit bigger and we're going to have more focus on the road than the buildings, and we want the buildings to be a bit smaller or bigger. So cool, we now have the tiles. You can see here they are. And if we go back to the actual loop graph, we can actually get the features. And the features are really cool. Actually, if I just used a visualize attribute now, we can change the attribute source to feature ID. So that way that is the attribute that we're going to be looking at. If I pressed A here and scroll to the right, there's feature ID. And you can see it says doors, windows, stairs, etc. And if we take a look here, look at that. We now know where doors, windows, and everything goes. Now, yes, this is not actually set up for a multi-floor story. Like the size of it, right, isn't in the right locations, but the point is the information is there. How we go from there remains to be seen. So now that we know that we have all these feature IDs, let's go ahead and filter by them. So we can actually use an Uber filter here if we so wish. So if I drag out and search for Uber filter, there's a few different ones. We want the cascade ones. Filter points into multiple buckets based on ordered filter groups. First matching group claims the point. Go ahead and select it. And you can see here, by default, it has 3 branches, which is actually perfect for us. So now we can go ahead and give it a filter to go 0 to 0, 1 to 1. So when it matches 0, it'll go out 0. When it matches 1, it'll go to 1. So we just right click here and search for compare string. And then you'll find PCGEx filter, compare string, right? And that's going to go into 0. And by the way, if you just drag out of the filter and search for compare string, if you have contextual still enabled, you just won't see it. Unfortunately, it's a bug in 5.8. So we just need 3 strings here. Now it's complaining right now because we haven't actually configured these strings. So let's go ahead and change the configuration of the first string. We're going to check if operand A, as in feature ID, is equal to Windows. And actually, because it's going to be easier, I'll just go ahead and duplicate this so that way I don't have to retype in feature ID. And then for the second one, we'll filter out the doors. And the last one here, we'll filter out the stairs. So if I go ahead and plug these in, we now have access to 0, 1, and 2. And now if we just use a simple debug here, for the windows, we can just give it an arrow. So let's use the S arrow here. It's throwing an error about the material, but That doesn't matter to me. I'll just change the extents here to absolute, so that way I can just scale it a little bit higher, because again, it's just for debugging here. And then I can just debug also the doors. I can keep it on the cube here, that is fine. But I'll just change the material here to be a PCG debug blue. And then the last one here, we'll use another debug for the stairs. And I'll just assign the PCG debug red material to it. So if we take a look at this, we're now filtering out based on the feature ID of that information. So now if we take a look here, well, we now have very interesting information. Now, these points are way too big. So let's go ahead actually and adjust them in the debug to make it a little bit easier. Instead of extents, I will change it to absolute. And we'll do that for both. We'll just set both of them to absolute. And there we go. Now we have the information. And look at that. There's a door there. There's some windows. We know where they go. We know where all of the doors and all of the windows go. And we have the information for all of this. Now, it's still not, a building. But the point is, right, we have gotten the information for a lot of these. There's all the doors here. There's some windows there. Now, it's hard to tell which floor they go on at the current moment, because you can see this one has actually 3 sets of floors. Some of them have only 2. So the building has its own shape. But the point is, we were able to take this actual generator, filter out every part of it, and now we can go ahead and just start spawning things on these locations. We have the points for them. We can adjust as needed. We can make pre-made buildings and just spawn them here, or use the actual dwellings information and make the modular ones as well. And we can build on top of this. The one limitation with this, and the biggest one, is kind of what you see is what you get, right? You're not going to now go in and be like, okay, let me just move these around. Let me just adjust this. And then let's say make this part a little bit narrower and move these over. I have ideas on how to do that. So if you guys really want me to dive into and see if I can figure that out, again, let me know in the comments. But nevertheless, even using the debug here, at a glance, you can tell where everything goes. You should be able to see how the information is being read and filtered out, and you can start spawning things already. I split the roads, but nothing's stopping you from just using the non-split version to spawn the spline meshes. You could check if they're overlapping the area inside the lake to know where you put a bridge, right? You could filter out this part. You can start building upon it. And if you want to make a new one, you can generate a new layout and use that. So it is really cool. Now, while this tutorial doesn't go in depth of like spawning things in and everything, I really just want to focus on getting the information in this tutorial, how to use the actual Watabou Bridge and how to read and utilize the information it gives it. That if you guys are interested in more, I'm happy to provide. With that though, as always, the project files for this will be available on my Patreon, where you can join these wonderful people in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything is down in the description below, as always, including the links to Watabou Bridge and any of the plugins that I used. And if you're thinking of creating more of a manual city yourself, well, I've done a little city gen series that you can see right over here to know how to maybe start incorporating some of the stuff you've seen in this tutorial with stuff here, because you can combine it all. I believe in you. You can do it. Go, go, go.